This is a Foucault pendulum. It's a pendulum that can move in all axes. When we move a pendulum, we expect it to move in the same axis that we pushed it in, like this. It becomes confusing when the entire pendulum is on a rotating object. Let's say this is point A and this is point B. From the perspective of an outside observer, it appears that the pendulum is moving in the same direction. But from the perspective of someone who's spinning with the object, the pendulum is changing directions. But what's making the pendulum spin? For that, we need to talk about fictitious forces. And I'm not talking about this force. We're talking about the Coriolis force. First, we need to understand what an inertia frame is. It's a frame where acceleration equals 0. This means that it could be a stationary object or something that's moving in constant velocity. Here, Newton's laws apply. A non-inertia frame is where things get funky. It's a frame where acceleration doesn't equal 0. An example would be our Foucault pendulum. Here, a fictitious force must be introduced to make Newton's laws valid. The Coriolis force is responsible for that change in direction. They're called fictitious forces because they don't actually exist. We just made them up to explain things better. Remember, the pendulum isn't actually changing directions. It's just that it looks like it is from our perspective. There are tons of fictitious forces, and you've probably experienced some. So next time, think twice before you say something is science fiction, because it might just end up being physics. Thanks for watching.